Good evening, everyone. Today's session is on number systems. Now, like in my previous sessions, I have explained you like how to convert a binary number into decimal or octal number into binary. Means any conversion you may uh, do so with the help of those methods. Now, today I am going to discuss about like when we have a fraction, when we have a fraction part in a number, how we basically convert it into the required your respective number system. So let's begin with this part. First of all, I will introduce like whenever we talk about digital is basically what is digital. Digital refers to a process that is achieved by discrete unit, right? In number systems, like whenever we use number system, each symbol has an absolute value. There is no basically there is no meaning of the decimal or fraction point number. But when we have fraction point number, that needs to be converted into the required number system, right? So let us see how does it work. So in a journal number system, the base, like if we have binary, then we having the base as 2. If we have decimal, then 10, octal 8, hexadecimal 16, and so on. Like whatever the base we have, that is called radix or r, right? And that can be written like this: you have any number, right? Then you have the fraction part over here, right? This is my fraction part, and then after the fraction part there are some decimal digits that are placed, right? So let us see how basically it is converted. This is my radix means your power, the basically the base part. Yes. So here y is the entire number, an is the value of n digit. Now let us see, like this is the formula from where we can apply the four types of number system. It could be decimal number system, it could be binary number system, it could be octal, it could be hexadecimal. Let us understand one by one how we convert it into different number system, right? So suppose we have a decimal point decimal number system. In decimal number system, we know that our digits, our numbers lies from 0 to 9. So we have the possible combinations that are between 9, and that has the base 10, which is again I have explained you, which is always less than the base. These combinations are always less than the base of that number system. So here the base is, the radix is 10. So our numbers would be combinations of 10 unique numbers, that is 0 to 9, right? It is a positional weighted system, right? Because here we have a certain position, we don't have a non-positional system. Like if you write in a Roman digit first, second, third, we don't have follow this type of weighted system when we are using the number system, because we need to refer each of the digit, right? The value attached to the symbol depends on its location with respect to the decimal point. So here we have the decimal point in our number, and then we decide the power according to that part, right? Like suppose for example, this would be my number, right? 9256. Again, this is my decimal number. How you came to like how you recognize that this would be my decimal point? Because it lies, the number ranges from 0 to 9. It has the possible combinations that lies between 0 to 9, right? Now let us convert this. So here when we are using the number system, how we convert it, it is basically here what we do is we can start with this part, and we divide the process into two parts, right? Here we have the decimal part, and before that we have the your absolute part, or you may say integer part, right? So here where we have the integer part, or after that we have the decimal part, right? So here what we do is, because it's a decimal point number, so our radix would be 10, right? And how we basically measure it, the part that is after the decimal point, we make the power as -1. Usually we have the 1/10, 100, 1000, and so on, right? The same process is followed here over here also. So like you have 2 6, so 2 into 10 raised to the power 1, and then into then plus 6 into 10 raised to the power minus 2. So when we have the fraction part, it is like always multiplied with the minus negative, because we are finding the 1/10 of that, right? So it becomes like this. And before that, we have already completed like how to convert this particular part. So here we have the your the basic part, that is 10 raised to the power 0 into 6 plus 10 raised to the power 1. So we basically usually move from here to here, and from this side so this is how a number is converted into, like how you calculate the decimal part also, right? The fraction part. Let us see the binary number system. Now in binary number system, like here we have possible combinations that lies between 0 to 9. The most important is the two things. The first is what is your range of numbers. That is, the second thing is what is the base of your number, right? So here we have the decimal point number, so we have to use the 10 as a base. Again, when we have a binary number system, binary is again a positional weighted system. It is not non-positional. The base of any number is 0 or 1. So that means we have the base as 2. It has two independent symbols. The symbols used are 0 and 1. And a bit digit, a binary digit is called a bit. The binary point separates the integer from the fraction point. So here, over here you have the integer part, right? And over the second part is your decimal part. So let's see with the decimal point number as binary number as well. So here we have the decimal part, and this is our integer part. So how to, the same method will be followed, but here we will be using the 2 as the base of it. So like it is starting with here, and I always remember 0 is not included in the fraction part. It always starts from this side, right? So over here we have any number, like suppose I am taking uh, any number, you can take it. So you might be having some numbers and you are converting it into decimal binary part, right? Then we have the next part, that is octal number system. It is again a positional weighted number system. And the weight, because it is an octal number system, though that means our base would be 10 or 8. The main thing is here you have to remember the two things, the base and the possible number of combinations. So you have octal number, that means the base is 8, always less than the possible combinations. So your possible combinations lies between 0 to 7, and your base is 8, it always less than the base, and the base is not included in the combination, right? And most important thing, it basically a combination of 2 to the power 3. When we check, when we basically segregates into like padding, in padding concept, we usually have the 2 raised to the power 3 digits, right? Now next is hexadecimal number system. Here it is again a positional weighted number system, right? The radix would be your 16. It lies from 0 to 9 and A to F, right? So basically it is 15, the last number, that is F, that is represented by 15, again less than 16, because 16 would be your base, right? So here the base is 16. Again this is 2 raised to the power 4. This would be represented like this. So let us take how we convert it. Let us see one by one how we usually convert these number system. So first conversion, we are using the method for binary to decimal conversion. So here we have binary number, no decimal point is there. So from here to here you process it from left to right, right, when you are processing the integral part, right? So you have the positional weighted system. Over here you have like this would be your 1, this would be your 0, and so on. So what you do is basically 2 raised to the power 1 into this. So here what we have is 1 into 2 raised to the power 0 plus 0 into 2 raised to the power 1 and so on, right? And you get your decimal number. So this is basically without the fractional part, right? There is no fraction in this. So when we have a fraction part in a number, how to convert it? Let us see. Convert this part to decimal number, and you have the fraction part as well, right? You have the fraction part as well. So here, over here we have some fractions and some integral part. Let us see how to convert it, because its base is what? 2. That means it is basically a binary number, right? And let us see how to convert it. So this would be my fraction part and this would be my integral part, right? So over here I told you, like whenever we are processing the fraction part, it is the raised to the power minus whatever you have the number, minus 1, minus 2, minus 3 and so on. So we have the first number as 1 into 2 raised to the power minus 1. The next would be your plus 0 into 2 raised to the power minus 2 plus 1 into 2 raised to the power minus 3, right? So this would be my integral part that needs to be solved, and this part is converted into decimal, right? And if we talk about this side from left to right, so we have the integral part. In integral part what we do is 1 into the same thing. You have triple 1 over here. So you just start with 2 raised to the power 0. Why we are taking the 2 as a base, as a radix? Because we are converting the binary number. So binary number has the base that is 2, right? So again plus 1 into 2 raised to the power 0 if we are processing this part. If we are processing this part. So over here we have the this part for 1, 1, 1. And for fraction part we have this part for fraction part, right? And that's why we convert it into a decimal number. That would be a combination of 0 to 9 digits, right? So this is how we are going to calculate our calculations for this binary to decimal number. Now let us see, let us take another example, that is binary to octal conversion. Now how binary to octal binary numbers are divided into 3 digits, because I told you if it is an octal number the radix would be 8. 8 means 2 raised to the power 3. So here the padding would be of 3 digits. Always remember this thing, because in none of the books you will find like how these are 3, because the padding takes place because of this thing according to the base, according to the radix, right? So starting the binary point and proceeding towards the left and right. Now let us see how it does it work. You have the octal number, you have the binary number, and it is from 0 to 7, right? Because we know that our base would be 8, so our combinations of digit would be lying from 0 to 7, that is less than 8, right? So you are, and one thing more, I have explained you the how it starts with. So you have a 4 combinations when we make the binary number, or when we make the representation 2 to the raised to the power 3 or 2 raised to the power 4. What are these combinations? 0, 1, 1, 0 and 1, 1. So you have the combination like this: 0, 0, 0, 1, 1, 0 and 1, 1, right? Over here we put 0, and when the 4 points have 4 numbers are completed, then we can start with 0, 1. So you have again 0, 0, 0, 1, 1, 0 and 1, 1. Now you put 1 as a first bit, right? So over here you put 0 as a first bit, and over here you put 1 as a base bit, right, as a starting bit. Now let us take one example. This would be my fraction part, and I am having in a fraction part what I am having, the basis would be, you have the fraction part. Okay, so here we know that 0 1 combinations are for what, are for binary number. So we are converting the binary number into octal number. So how it converts, let us see. So basically we will use this chart for this. We know that first of all we segregate into different digits. So let us segregate from here, integral part first, and then we will convert into. So here we have 2 raised to the power 3 as our uh, octal combinations. So here we have this combination. Let me show you with the highlighter so that you may understand it better. 0 1 0. Then again I am taking the yellow color for another combination, and then it would be like this. So this would be my uh, like how you convert the digits. So here this would be my 110, then 010, then 111, and then 101. The same is for this side also. You take it as 110, then 110, then 011. Right, so you have done the you have basically convert each bit into 3 groups. It is basically converted into 3 groups. Okay, so let us see how it works. Now we know the binary representation for these numbers. 101 over here, we can see that it is 5, so we directly put it as 5. Then we have 111, that basically represents 7. Then 010, it is representing 2. So you are putting in place of the that particular binary number and making the padding of 2 raised to the power 3. So 3 digits are padded into one group, right? So let us see another example. It would be like this. So over here we have, now here this is very very important. Why? Because I will be telling you about like how it, when it does not make the padding of 3 in one group, how it works. So over here we have first, then second padding, then you again make a group of this. Now over here only 2 digits are left. Okay, let's see from here also. Over here again 1 digit is still left. So how to go about this? Here we have one thing. This is your first bit, this is your first group, this is second group, third group, and this is your fourth group. So to complete it, you put 0 over here before that. And always remember, when you have the fraction part, you put 0 at the last, not from the beginning. So in the beginning, we will be having 0 when we have in the integral part we have 0 from the starting, and in the fraction part we have 0 at the fraction part, right, at the end part, like at the ending of this part, right? So here over here we can say that like whenever we use this, right, whenever we use this, we have to use with the help of like we cannot have the basic things. Like if you put 0, so you are putting 0 over there only. You cannot put 0 from the other side, right? So here we will be having such condition. Okay, so let us see in this part how does it work. So we have the padding of 3 digits, right? Then next 3 bits in one group, then next 3 bits in one group, then next 3 bits in one group. So we have different the three groups, but the only thing is when we don't have any number, like if it is of only 2 digits, like 2 binary digits, then we are putting 0 in the on the left hand side, and when we have last fraction digit, we are putting 0 at the right hand side. So this is our main motive, like how we convert it and basically how we use them, right? And this chart is followed. I told you this would be a combination of this. First you put 0 for first 4 digits, and then you put 1 for next 4 digit, right? And then you make the number. So it would be from 0 to 7 because we have the octal as a base, as a radix. Let us move to the next number. So here now you will get the answer for, this is my integral part and this would be my fraction part for the octal number, right? Let us see for the binary to hexadecimal conversion. So hexadecimal means 16. 16 means 2 raised to the power 4. So your padding will be, your each group will have the 4 digits, right? Because it is 2 raised to the power 4. So let us see, the same combination is followed. You have 0, 0, 0. Again, the same thing would be followed. That is same as your binary part. In first 8 digits, you are putting 0. In next 8 digits, you are putting 1. And the same part is followed like what you have in your octal format. So this is my octal format for 7. So over here for the first 7 digits will be your, because it is containing 15 digits. Right? So this is how you are going to calculate. Let me tell you, the same combination is followed: 0, 0, 0, 1, 1, 0 and 1, 1. Right? Then we have, then we start with over here. You have 0, 1, 0, 1, 0, 1, 0, 1 and the same combination 0, 0, 0, 1, 1, 0 and 1, 1. Then we have 1, 0 combination. Let us see. 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Then we have last combination for 1, 1. And we put the same combination for it also. Right? And in front we put it 1, 1 because this was my last digit. And over here we know that because it's a hexadecimal number, so you have the 16 as a base. And let us see what is the binary representation for it. So over here we don't have any fraction part. Directly we can solve it. We can make a combination of group of 4 digits because it is 2 raised to the power 4. So over here you start from left to right when you have the integral part. So 1011 would be my first digit, first group. Second group would be my 1101. This would be my second part, and 10. So here I told you in the integral part we have the 0, 0, right? So here what we do is, now we can see that what is the representation of 1011. It would be my B, 1011. What is 1101? It is my D. So over here I will put D. Then we have 0010, 0010. That is my 2. So this would be. So this is how it is converted into a binary number to hexadecimal part. Let us take a fraction number as well. So you have this part again. Understand clearly like how does it work. It would be my fraction part and this would be my integral part, right? Now over here, because it's a hexadecimal number, we have the 2 raised to the power 4 bits. So we are making the groups of 4. From left to right, if we are moving from over here, integral part, fraction, this integral part, and then we have fraction part. So here we have the 4 digits. The first 4 digits is here. Then second 4 digits, 1, 2, 3, 4. This would be my second 4 digits. And then if any digits get left, I told you, you put 0 in front of that. So this would be my integral part. The same is followed for the fraction part. This is my first 4 digits, 0, 1, 1. Then again only 1, 1 is left. So what you do, you put 0 over here at the end part, right? And then now you apply the table over here. So your table would be representing like this. It will be like 1100. So 1100 would be my C part. So here I will put C 0111. So that is 7. So over here I will be having 7. Then 1011, it would be my B, right? Then 111, it would be my F. Then 0010, it would be my 2. So over here you will put 2. So this is how it is converted into binary number is converted into hexadecimal number, right? And you just write your hexadecimal as a base for it, and always remember this table, like how we use this table over here. Let us take the next one also. Decimal number system, decimal to binary. Decimal number, we have base as 10, radix as 10, and binary, we know that binary is basically the base as 2. So let us see how we convert it. So over here we have a number that is 52. So let us see the binary representation over here. We just multiply, we just divide it with the number, and until you get 1. If you get 1 over here, you just put it 1, and then whatever the number remains, it would be like this, right? And then you basically go from here to here, right? This is my most important bit. So here we will be writing like this: 110 and 100, right? This would be my basically this we have already completed, but we haven't completed for fraction part. The same thing is for fraction part. In integral part, the same process is followed that we have followed over here, but let us see how we convert it for the point part. So 0.12, and what is my binary base? That is 2. So you take it as 2. Again this 3.0 is multiplied by 2. Again this part is multiplied with 2. Then so on, like if you have any number now over here, like 0 1 0, don't multiply with that number. You have to multiply only the decimal part, only the fraction part. So over here what you do is you basically take out the fraction part and multiply with the number base, that is radix 2. So here like 20 0.20 into 2, 0.40 into 2, 0.80 into 2, so you will get this number. Now how you convert it? Basically you directly write it down. So over here how you get this is this part, yes, 0 0 1 0 0 1. So you will get the fraction part from here, right? So always remember you are going to calculate like this, right? So I hope you have like understood what we have covered today, and in the coming sessions I will be telling you about the remaining ones, how we convert the decimal part into the octal conversion, and if it would be a fraction part, right? Hope you understand like how we convert it and how number systems uses the base, and base plays an important part. The most important thing is padding. When you use the 2 raised to the power 3, how you make the groups in number system, and all these number system are positional weighted system, because for a computer system we cannot have the non-positional computer system. We usually refer to the positional weighted system only. Hope you understand the session. Hope you like the session. Thank you.